Compute the average value of the following function over the indicated region. And here we have f of x is equal to 3 times sine of x times sine of y, and R is the set of all ordered pairs x, y, where x is greater than or equal to 0, less than or equal to pi by 4, and y is greater than or equal to 0, less than or equal to pi by 3. So let's first recall what the average value for this function is. As we say, the average value is f bar, and it's equal to 1 over the area of the interval. So we have b minus a, the length of x, multiplied by d minus c, which is the length of y, multiplied by the double integral over r of f of x y dA. And then noticing here that we have a rectangular region, our differential can either be dx dy or dy dx. So that is up to you, and again, I challenge you to go through both to make sure that you find the correct answer. So I'm going to find the area of this region first. So again, the area is going to be b minus a multiplied by d minus c. And plugging in our x values, we have pi over 4 minus 0 multiplied by the y values, or the length of our y interval, pi by 3 minus 0, which leaves us with just pi over 4 multiplied by pi by 3, for a beautiful final answer here of pi squared by 12. So we'll come back to this at the end when we compute the average value, but for now we want to go ahead and compute the double integral, or evaluate the double integral. So I'm going to put my x bounds on the outside, so I have the integral from 0 to pi by 4, and the integral from 0 to pi by 3 of our function 3 sine of x multiplied by sine of y. And then because the y bounds are on the inner integral, we put the differential dy first, followed by dx. And the first thing that we want to do here is evaluate the inner integral. All right, so we're taking that out. And I'm going to pull, because we're integrating with respect to y, I'm going to pull 3 sine of x onto the outside here. And it's multiplied by the integral from 0 to pi by 3 of sine of y dy. And we're ready to integrate, so this becomes 3 multiplied by sine of x, and sine of y integrates to minus cosine of y. And we're ready to evaluate from 0 to pi by 3. So I have minus 3 times sine of x multiplied by cosine of pi over 3 minus cosine of 0. So this simplifies to negative 3 times sine of x multiplied by 1/2 minus 1, which leaves us with minus 3 sine of x multiplied by negative 1/2, which we can simplify to 3/2 sine of x. So that is our inner integral. And we're now going to substitute this into the outer integral. So we are ready to evaluate the outer integral. So we are integrating now with respect to x. So we have 3/2 times the integral from 0 to pi over 4 of sine of x dx. So this integrates to negative 3/2 multiplied by cosine of x from 0 to pi over 4. So we have minus 3/2 multiplied by the square root of 2 minus 1. And we can simplify this a little bit further. We could rewrite this as minus 3/2 multiplied by the square root of 2 minus 2 all over 2 by getting that common denominator. So we are left here with minus 3 times the square root of 2 minus 2 all by 4. So this isn't our final answer, though. This is just the exact value of our definite integral. So now we're ready to actually find the average value of f. So again, we know that f bar is the double integral over the region R, f of x, y, dA, and it is divided by the area, so b minus a, multiplied by d minus, not c, not a, it should be c. There we go. So plugging in everything that we just found, and we've just evaluated the double integral and have minus 3 multiplied by the square root of 2 minus 2 divided by 4. And the very first thing that we found was the area, which was pi squared over 12. And we, of course, recall that fractions in the denominator flip. So this becomes negative 3 multiplied by the square root of 2 minus 2 divided by 4 multiplied by 12 all over pi squared, which we can simplify. We know that 4 goes into 12 3 times, leaving us with a beautiful final answer of negative 9 multiplied by the square root of 2 minus 2 all over pi squared. And this is our final answer here for the average value of f.